There are different type of bonding, but our focus today in the class is going to be the ionic bonding. Now, as the name itself specify ionic, so ionic bonding will be a kind of a force of attraction which will be between the ions. So let's understand what are basically the ions. Now, if I need to define ions, and I'll say that the ions are the charged particles, right? They are the charged particles. Now, what do I mean by the charged particles? We already know that the atoms are said to be the neutral particles. Now, why atoms are known as neutral particles? The reason for atom to have a, they are called neutral particles because in an atom, the number of protons are same as number of electrons, so they don't have any charge on them. But the ions being the charged particles, they either have the more number of electrons than the proton. There's a mismatch between the protons and electrons. There's either the more number of electrons than proton, or there are more lesser number of electron than protons. Now, because there's a mismatch between the proton number and the electron number, that is the reason we have the charged particles and we call them ions. Now, we need to understand that why the atoms, they form ions. What is the reason? Why is it so? Now, we know that the elements, the group 8 elements are known as noble gases. Now, these are the gases which are very stable in nature, that all the elements, they want to acquire the stability like the noble gas configuration. They want to be stable as noble gases, right? Now, why are they stable? They are stable because their last shell electrons are either 2 in the case of helium, or they are 8 in the case of neon, in the case of argon, in the case of xenon, and so on. And that gives them the stability because the last shell, if they have the 8 electrons, that means they're stable. They are, so all the elements, whether they are metal, right, or they are non-metal, they try to be stable. Now, they try to be stable just like noble gas, right? So they either donate the electrons like metals. The metal either belong to group 1, or they belong to group 2, or they belong to group 3. So they, in the last shells, they have 1, 2 or 3 electrons. तो अगर वो अपने लास्ट शेल के 1, 2 और 3 इलेक्ट्रॉन्स डोनेट कर देते हैं, तो वो नोबल गैस की स्टेबिलिटी, उनके लास्ट शेल में 8 इलेक्ट्रॉन्स बाकी रह जाएंगे. Whereas the noble non-metals, they have either 5 electrons, 6 electrons, or 7 electrons. They belong to group 5, they belong to group 6, or they belong to group 7. Up, in order to have the noble gas configuration, the stability, the last shell of stable electrons, the group 5 elements require 3 more electrons, so they will be receiving or they will be gaining the electrons. Okay? Or similarly, group 6 elements will be acquiring 2 electrons. Group 7 will be acquiring 1 electron in order to acquire the nearest noble gas configuration. So metals and non-metals, they either donate the electron or they gain the electron in order to have a noble gas outer shell electrons. And for this reason, there is a mismatch between the proton and electron number, and that is the reason they form ions, right? So the metals, they form the ions. Similarly, the non-metals, they form the ion. The reason is because they want to have a noble gas stable electronic configuration. So now we know there are 2 type of particles. Now the number 1 particles are basically atoms. In the atoms, there are the type of particles I'm talking about. Now, there are 2 type of particles, number atoms. There, the number of protons and number of electrons are same. That is why they are said to be neutral particles. They are neutral in nature, right? Reverse of them, opposite of them, we have got ions. In the case of ion, the number of proton and electron are not equal. Now, because the proton and electron are not equal, that is why they are charged in nature. They are charged in nature, right? So they are either positively charged, okay? Either they are positively charged and known as cations, or they are negatively charged and they are known as anions, right? Now, if this is a neutral atom, if the neutral atom, if the neutral atom, they donate electron. Like for example, I take example of sodium. Sodium's configuration is 2, 8, 1 because its atomic number is 11. So now what is happening here? If it has to have a stable noble gas configuration, it will be donating its one electron. So on donation of one electron, its number of protons remain same as 11, but number of electron has become 10. There is a mismatch. That is why it has one proton extra. So it will be forming a cation, which are basically positively charged, right? Now let's consider another example. Let's take the example of chlorine. Its atomic number is 17. Its concentration is 2, 8, 7. Now, in order to attain the nearest noble gas, its last shell should be completely filled. It should have 8 electrons. It is short of 1 electron. So what will happen? It is going to acquire 1 electron, right? On acquiring one electron, its configuration will be 2, 8, 7. But then its proton will remain 17 and its electron will become 18 on acquiring. There is again a mismatch here. There's one electron extra. So this is going to form a charged particle which is negatively charged, and this is going to be known as anion. So this is how the neutral atoms, right? The neutral atoms, they form the charged particles, either cation or anion. Now, always remember that the cation, the metals, they always will be forming the cations because they belong to group 1, or they belong to group 2, or they belong to group 3, and they lose 1, 2, or 3 electron in order to attain the nearest noble gas configuration. And the non-metals will always form the anions. Now, why? Because they either belong to group 5, or they belong to group 6, or they belong to group 7, and they accept, or they acquire the electrons in order to be like the noble gases. So they have the electrons more as compared to their proton number, and they form a negatively charged anions there. Okay, let's see the examples of the metal, how the metal will be forming the cation. Now, this is a metal. The metal is aluminum and it is going to form a cation. That means it's going to form a positively charged ion. Now, we know that aluminum belongs to group 3. Now, belonging to group 3, that means it will be having 3 electrons in its last shell. 1, 2, and 3. Its configuration is 2, 8, 3. So it has 3 electrons in its last shell. So in order to have the nearest noble gas configuration, it has to shed off its 3 electrons. So it will be donating 3 electrons. So on donating 3 electrons, its number of protons remains 13, but its number of electron has become 10. And that is the reason it has acquired a charge of 3 positive because its proton number are 3 more than the electron. So that is how the metal aluminium will be forming a cation, which is a 3 positive charged ion. Now, reverse to that, when we talk about the non-metals, now let's take the example of oxygen, which belongs to group 6. Now, belonging to group 6, it will be having 6 valence electrons. Now, 6 valence electrons means that if it need to have a noble gas configuration, it is short of 2 electrons, right? So let's see, does it have? So its configuration is 2, 6. It has got 6 electron, 1, 2, 3, 4, 5, and 6 in the last shell. So in order to have the nearest noble gas configuration, it need to have 2 more. So it will be accepting 2 more electrons. So basically its number of protons will remain 8, but its number of electrons will become 10. So there is a mismatch. So it will be acquiring a 2 negative charge in order to form an oxide ion. Okay, till now we have So till now, we have just seen that how the metal form cation and how the non-metal form an anion. So this is a metal which is sodium. So it is going to form a cation here. This is a cation on losing an electron. This configuration is 2, 8. Now, whereas a non-metal will be acquiring and it will be forming an anion. It is losing an electron. This is acquiring an electron. So these are two ions. This is cation and this is an anion. They are oppositely charged. They're oppositely charged ion. This is a positively charged ion and this is a negatively charged ion. So this is a cation, which is a metal ion. This is a metal ion. And this is a non-metal. This is a non-metal anion, which is a negatively charged. They both are oppositely charged. So when both the cations and anion come together, there is a force of electrostatic force of attraction between them, right? Because they're oppositely charged. Similarly, just like the opposite poles of a magnet. So they are strongly attracted. This force of attraction between the oppositely charged ions is basically known as ionic bonding. Is known as ionic bonding. As I told you that bonding is nothing but the force of attraction. So now here the two different type of ions are there and the force of attraction between the two different type of ions will be known as ionic bonding. So let's define what is ionic bonding. So ionic bonding is basically an electrostatic force of attraction between a cation and anion. Okay, so this force of attraction is known as ionic bonding. Here we have another example of another ionic compound. This is magnesium fluoride. So ionic compound is always a compound which is formed between a metal and a non-metal, because a metal is losing an electron, is donating an electron to a non-metal. So that is an indication that always an ionic compound will be formed between a metal and a non-metal. Like for example, we have magnesium oxide, we have magnesium chloride, we have sodium oxide, we have sodium fluoride. So always that's an indication it's always between a metal and a non-metal, right? Now over here we will be observing the similar dot and cross diagram between the magnesium fluoride. All right. Now here this is a magnesium atom. This is a magnesium atom. It has got two electron in the last shell. So it has to donate two electron in order to have a nearest noble gas configuration. Now these two electrons are donated one to one fluorine and another one to another fluorine, because the fluorine has the configuration of 2, 7. So it's short of one electron. Similarly, another fluorine is also short of one electron. So this magnesium will be giving one electron to this fluorine and one to this, and it itself is going to form magnesium ion with the charge 2 plus, because it's losing two electron. And both the fluorides, fluorine, are going to form the fluoride with a negative charge, F negative. Now, similarly, we have seen here, see, this is magnesium in the center. Now has a charge of 2 plus. Why? Because its number of protons remain the same, but the number of electron it has lost 2 electrons. And the fluorine, we can see this red electron. This is an acquired from the magnesium. So each fluoride will be acquiring a negative charge like this. So this is the force of attraction. The force of attraction between these cation and anion, between this cation and anion, is known as ionic bonding. So ionic bonding is an electrostatic force of attraction between a cation and an anion, right? So here we can see this is a force of attraction between the cation and anion, and this is known as ionic bonding. Now, in a past papers, we have seen two examples. Right now, we have seen two examples. One is of sodium chloride, another one is of magnesium fluoride. They often ask you in past paper that which is out of these two compounds, which is going to show a more stronger ionic bonding. जितने ज्यादा इलेक्ट्रॉन का ट्रांसफरेंस होगा, यहाँ पर हो क्या रहा है, एक डोनेट कर रहा है और एक एक्सेप्ट कर रहा है, तो बेसिकली आपका क्या हो रहा है, द इलेक्ट्रॉन ट्रांसफरेंस हो रहा है। नाउ इलेक्ट्रॉन ट्रांसफरेंस जिसके अंदर भी ज्यादा होगा, अब यहाँ पर ट्रांसफरेंस ऑफ इलेक्ट्रॉन कितना है, 1 इलेक्ट्रॉन ट्रांसफरेंस है, और इनके बीच में क्या है, इनके बीच में भी एक ही इलेक्ट्रॉन ट्रांसफर है, ठीक है। लेकिन अगर हम देखते हैं मैग्नीशियम ऑक्साइड के बारे में, तो मैग्नीशियम ऑक्साइड, मैग्नीशियम 2 इलेक्ट्रॉन एक ही ऑक्सीजन को देगा, तो ये 2 इलेक्ट्रॉन्स हैं, ठीक है। अगर हम देखते हैं NaCl, और इफ दे आस्क अस द क्वेश्चन दैट आउट ऑफ दीज टू कंपाउंड्स which is going to show a stronger ionic bonding, then we'll say that because the transference of electron is more in magnesium oxide, there are 2 electrons being transferred, whereas in sodium chloride there's 1 electron transfer. So the 2 electron transfer is going to make us more stronger attractive force between the cation and anion. So here the bonding is going to be, in this case, the bonding is going to be stronger. Okay, because the 2 electron transfer is taking place as compared to sodium chloride.